Garrett.
Freaking on there.
Hey, this is Dr. Garrett. So tonight we're going to talk about some really great stuff. Epigenetic approaches to treating anxiety and depression. Holly will be joining us here soon. And I want to thank you guys for being a part of this, of course. This is our third talk this month. And so the next one we're going to be talking about case studies and success cases of how we applied all this stuff that we talked about for the first three classes here at the live feeds. So make sure that you guys take some time to like the video, to share the video. This should be fairly unique stuff that we're going to talk about tonight. And really, within this realm, this is absolutely cutting edge information. And so even me and one of my fellow practitioners, we're actually starting clinical trials at KU and WSU for what's called proteogenomic psychiatry kind of research. And epigenetics, hopefully we're going to have the epigenetics in the first line of research. If not, we'll do it in the second. But it's applied through all these other fields of healthcare, but nobody really looks at genomics, and no one really looks at epigenetics, especially for anxiety and depression. So not only is it cutting edge, it's almost not heard of really within psychiatry, at least the practice of psychiatry. And so what we're going to talk about is what research already shows, and like we keep saying is, you know, you have 17 years of between where research enters into clinical practice. So all we're doing is skipping that process and really trying to get the best, fastest outcomes by using evidence-based models. So there's Holly. So as you guys know, I'm Dr. Patrick Garrett. I practice functional lifestyle medicine. I have a doctorate in chiropractic, been to medical school, have postdoctoral diplomates in clinical nutrition, functional medicine, integrated medicine, and post-grad continuing education through lifestyle medicine program through Harvard Medical School, Yale Medical School. So essentially, big super nerd, here to help people. So, and then I'm on several boards and a whole bunch of other kind of nerdy stuff. And then Holly's here, and Holly's our one that as I try to like get like crazy detailed, she's the one that's going to help us humanize this and bring the conversation back down to where people can understand it.
To where humans can understand it.
That's right.
I'm Holly Hajjaj. I am the wellness director here at Integrated Wellness Solutions here at AFC. So I coordinate a lot of our wellness activities like Tai Chi and yoga, Pilates, meditation. I also am a certified yoga instructor. I teach some of those classes. I'm a certified personal trainer on the track for doctor of physical therapy. And I believe wholeheartedly in holistic and natural solutions for our well-being, which is why I'm always excited to be here to talk about this and to learn so much of what's in this one's brain, because there's a lot.
So then we'll call you Dr. H2.
Dr. H, double H, right?
Double
H2, H squared.
I like that.
Right.
So, all right. Well, so our theme this week is genomic approaches to anxiety and depression. Typically, I don't have my sheets in front of me, but today there's a lot of complication, a lot of details, and so I'm going to be more like an anchor, I guess, anchor doctor. So that's why we have the sheets here today, and I got all kinds of packets and stuff. So if you guys have questions, feel free to obviously post them. It's good to see a lot of our people here that attend regularly. You can also view this offline too, which is really nice. I think we typically have between like, I don't know, 5 to 1,200 views. So it's good that the information is getting out there. So please share it. Today's topic, epigenetics. So what the heck is epigenetics?
What the epigenetic is epigenetics.
So Holly, take that away.
Everyone, I can't wait to share with you what I know, which is practically nothing. So I'm going to let Dr. G take it away.
All right, I guess I have to work here. So with epigenetics, I love epigenetics. So last time we drew out a whole bunch of stuff, and I wrestled in my brain like, how complicated should we make things? So hopefully it was just enough detail to legitimize it with enough layman's terms to humanize it, I guess. But with epigenetics, we talked about we have DNA, and the DNA is basically uncoupled from chromosomes, which we get from our parents. And we have histones in there which tell us what that DNA should look like, so every time we replicate DNA. So every cell in your body has its own copy of that DNA, and all the cells should have the same copy of DNA. Within that DNA, as we spread that out, we get that double helix kind of twisted staircase, and there's certain section of those that are called genes. And then those genes code for what are called kind of like phenotyping, or they code for how we think, how we behave, how well we do, our basal metabolic rate. If you have someone that, you work in this cubicle, and if you think about a brownie fudge, you like gain 2 pounds. And then you got some jerk in the other one cubicle, not her, but this someone.
He means me.
Yeah. And they could eat like the whole plate of brownies and lose weight. We all know those kind of people, right?
Right.
And the only difference is that basal metabolic rate, and that basal metabolic rate is then determined by several genes that act from the DNA. So genes are active parts of our DNA, and gene expression is kind of what we see and feel. And the epigenetics, though, is our ability to actually regulate and modify those genes in. So most people think like disease is genetic, but it's only,
1%.
1%, right? So even your milk has more percentage than what we attribute to genetic disease. So true genetic disease is only really 1%, which means if we see stuff in a family, it's just because if I do what dad does, I get what dad got, kind of thing. So typically it's trending in families because of continuity of what they do, not genetics. So then the rest of that 99% of all diseases that we suffer from are really what are called maybe epigenetics, which is gene outcomes. And so you'll hear people say, well, I have a genetic predisposition for this. Well, great, don't have that, right? I mean, it's not your destiny. Your genes are not your destiny. You have great control over that. So epigenetics is our ability to turn on and off those genes, silence genes, demutate genes, so that we get this kind of, actualization of who we want to be. Does that make sense?
Yes.
Probably not.
Yes. I did have a question on that inheritance. I was doing a little bit of reading on my own and found the phrase epigenetic inheritance. So, can you explain a little bit about the difference between epigenetic inheritance and genetic inheritance?
Yeah, so I have blue eyes because it's a recessive gene, and my mom and dad both have blue eyes. So, in fact, we have 4 daughters. Me and my wife have blue eyes, and all 4 of our daughters have blue eyes. So that's pretty rare as far as having the recessive gene keep being passed through. But that's that kind of what we might say harder genetics. Like my eyes won't change color through my lifetime, mostly, right? They'll never go from blue to brown or brown to green, but they might change colors just a little bit depending on health. So that's that kind of hereditary genetics that's a little bit harder coded. The softer kind of heredity is if my dad had diabetes or my mom had anxiety, she will make different biochemicals, and when I'm in her womb, those chemicals affect me in usually a detrimental way, or so then it would make me more likely to be anxious or depressed. So if mom's anxious and depressed, then baby's more likely to be anxious and depressed.
And that's typically what people have been attributing to hard genetics.
Right.
They've been thinking, okay, if this is fixed and mom has this, then I have this, and it's unchangeable.
Yes.
But that's not true.
It's not. And there's a gene called, there's several different genes. This is part of my research here. But you see this list. This is 2 pages of genes that are directly linked to very specific health conditions. And with anxiety, there's about 3 genes that we have to worry about. But one of them's NGF. So this is a really interesting way to explain this. Is NGF has to do with glucocorticoids, which basically it's stress. All right, it's sugar that's created through cortisol hormone to make stress. So if mom is always upregulating that gene because she is chronically stressed when she's pregnant, then your physiological reaction to your genes being passed down in the womb is to downregulate that. So then when you're born, you have less ability to then cope. Mm-hmm. And that's done through that soft genetic pathway of epigenetics. Now, does that mean you will always be depressed if your mom was depressed?
No.
No, it's not. And we know that because people that come from crazy screwed up families can turn out perfectly fine, right? So like every family has that one black sheep. Well, black sheep families have that one, normal kid. That's me.
We've got a lot of people showing up tonight. By the way, great to have you all. Please comment and question, and just any burning thoughts or questions, please type them in and send them to us. We are watching. We had one question on this topic. Heart disease also, or more just psych issues?
Well, all conditions. All conditions. So like my dad had diabetes, right? And my genetics would say I have a predisposition for diabetes. And what that really then tells me is I have to work harder not to be my dad, not to have the disease of my dad, not to have that genetic outcome. So that predisposition that you'll see only allows you to, it should be only viewed as I got to work harder than other people to not have this condition.
Is it work harder, or is it just change and do something different?
All right, change and do something different. Right, absolutely.
Okay.
Absolutely, yeah. So, that's that thing of like, since my dad died of diabetes, I make sure that my A1C stays around 5.4 just through lifestyle. So I, again, am not perfect. It's always process over perfection. But I ensure that all those little things that I do, that I try to maximize good, minimize bad as much as possible to ensure that I don't suffer from that. And that my children don't suffer from that too.
Yeah. I have another question.
So that's any disease, heart disease, cancer, diabetes, all that stuff. It's the same.
What is the what compromise? What is the 1%? What is the 1%?
Well, so for the 1%, that's through what's called a cytogenetic report, and we look for DNA, physical DNA mutation. Now that is not coding issues. That is the whole, you might have a sentence where maybe you, if you say, I read books, is that read or read? I don't know, right? So you can kind of say that there might be two outcomes to that. But with hard code genetics, the whole sentence is broken up. It's not a real sentence. So if you look at something like 3 codes, or the one codon, 3 little codes that make a codon, if it's flipped around in your DNA at the right place, which is trisomy 21, then that mutation will cause Down syndrome.
Okay.
So that's a hard code genetics.
That's an example of one
right.
hard code genetic. Okay.
So while we typically think that is permanent, that's you could inherit that, you could cause mutation of that at any point, and you get this actual trisomy 21. So then the question becomes in my mind of you're supposed to reverse DNA. You actually have this thing called DNA polymerase, which actually goes along that DNA, reads the histones, and then determines whether the rest of that code is perfect. If it's not perfect, it's supposed to chop out that trisomy 21 and put in the right code, and then you just keep replicating the right code, and then you become normal, right? Well, there was a girl, I remember when I first started practice, that had trisomy 21, Down syndrome, up until about 9 years of age. She did epigenetic therapy or nutritional therapy that was very specific, and by 13, she had normal features, and I would say normal, right? But she had non-Down syndrome features, and the spacing of her eyes, all that kind of stuff changed. It all changed. And she was in honors classes. She started playing musical instruments, and it was amazing. And she made the cover of MD News, and she was on Dateline in 2020, and her mom wrote a book, then she wrote a book. But we just ignore it. It's just like it happened. Okay, well, that's great, but that doesn't apply to the rest of us. But the reality is, even hard code genetics we should be able to change through that epigenetic process.
Wow. That's incredible.
Yeah.
I've never heard of such a thing ever.
Right. And because of that, I knew it was possible, and I actually have 2 cases where we've done that we're going to try to publish.
Wow.
So, even the oncologists had never seen that happen before, and the parents were amazed, and the family was amazed. But it's what my DNA does every day and your DNA does every day. It's just, why didn't their DNA do it? Well, they were poisoning their DNA with things like benzene that we know cause that hard code genetic mutation. And as long as they're doing that, they're going to keep getting the same outcome.
Yeah.
And when we talk about, so one of the things we want to talk about today is what are the simple things that you can do to just completely help your DNA. And when you look at those foods, it's kind of like, oh, well, I don't eat like that. Nobody in America eats like that.
Yeah.
Maybe we should just start eating like that.
Yeah. Rachel's asking, do you remember her name?
Oh, I can't tell you names? That's a HIPAA violation. You're
one
trying to get me in trouble.
The one who was published.
Oh, that little girl. Okay. Rachel, I thought you were trying to get me there.
Sabotage.
Saboteur. All right, so I used to know it, but I think if you Google it, you can find out. Like if you just put reverse Down syndrome, little girl, I think you'll find it very easily. I had to look it up not too long ago because, again, some of these things, it's just like, oh, can that really be true? Like,
right.
I quote research all the time, and then after a while, I'm like, geez, that seems too crazy. Is that really true? And it's like, then I'll look it up again.
Yeah.
So you shouldn't have a problem looking it up. If not, let me know, and I can try to look it up for you too.
I have another question just on epigenetics and the changeability of genes. Is that changing throughout your day?
Right. Well, it's all the time. Yeah.
All the time. You could be turning on the good ones for an hour one day, and then that day, and then you could.
Well, probably theoretically, yeah. But a lot of the stuff, there's the bulk of the versatility is going to be kind of muted. Except for chemicals that we consume that are messing up those pathways on a consistent basis. Okay. So there's lots of chemicals that we eat and drink and breathe and rub on our skin that cause instant mutations, and then your body's whole job is to try to fix those mutations. So it's constantly waxing and waning, if you will.
Are the mutations instantaneous, is what you're saying?
Well, theoretically, yeah.
Okay.
Yeah.
Okay. There's still a lot we don't fully understand.
Right. It's crazy. And I have a book here, which I bought this book when I first had the really fatal genetic disorder with a kid I had to try to fix. And so I spent my week in Colorado at the cabin with everybody else playing, having fun. I was reading a book that's all research, but it's nothing entertaining about this research whatsoever. It is
dry.
Yeah, I'm glad I have 12 years of graduate school because it takes all that just to get through this. Because it's all the biggest words ever, nonstop, every single page. And then every chapter is a thin chapter, and then it has almost that amount of references of research to justify that chapter.
Yeah.
It's an incredible amount of research. But when I bought this, I thought it's called Nutrients and Epigenetics. And I wouldn't buy it, even though it's incredible. It's one of the few books I've written in, but it really changed clinical practice for me when it comes to epigenetics. But when I think I first looked at this, it was $125. And I thought, oh, that's a pretty big textbook. That'll be pretty good. And then I was just I'm too cheap, and I waited. And I think I finally found one for $85 at some point. And I got it, and it's this dinky little book. But it's the most amazing amount of research.
Because of the amount of work that went into it, yeah.
Right. So this person, I don't know if you'd want to have a conversation with this person, because I think they would just be only details, no fun, nothing. It's just so. And I have other books on epigenetics that are all kind of fun, entertaining things with a little bit of research, but they aren't practical use kind of things, though.
Yeah.
So I had to transition what I learned in that book and taking that research, and I said, okay, how can we make that a clinical protocol for patients?
His book is next.
Yeah, that's right. Mine's the easier version with lots of meat on it, you know.
Right.
So when we were talking about that NGF gene, right?
Okay.
So we talked about stress and if mom's stressed, right? So one of the things that this research talks about is that gene for anxiety. It regulates hippocampal glucocorticoid receptor genes. That's the whole process. What that means is how well do I make stress hormones to cope with things. But it says the neuropsychopharmacology of parenting has to do with those showing increased nurture while they're a baby actually have increased hippocampal glucocorticoid receptor gene expression. So literally, if I hold my baby, if I pat my baby, if I love my baby, if you breastfeed your baby, if you do all these kind of nurturing things all the time with your kids, then your kids actually turn on that gene and express it fully to where they can cope.
Right. It's adapting,
Right.
being able to adapt.
And then they showed that the inverse was true, that if the less attention, the less nurturing you spent with that child, the less that gene was expressed, and the less ability that kid had to cope. So that would be the difference between the same stimulus causing anxiety in one, nothing in the other, and overwhelming suicidal kind of anxiety in another person, is through that one basic pathway.
Yeah.
And again, if you're a mom, you can't, parents is when if your kid's Dexter already and chopping people up and put them in the ocean, well, you can't really help that gene at that point, right? So that's not. But what can you do afterwards? Well, we can still change how that gene affects, and that's through things like altruism and mindfulness. So even if mom didn't give us what we needed, well, then we can still regulate and upregulate that gene through epigenetics and the epigenetics of what runs that gene, which is nurture. So that mindfulness, that meditation, that yoga, that actually nurturing yourself and taking care of yourself instead of eating for your hormones and distracting with TV, you can literally change those genetics that way.
And a support system of good people who are nurturers.
Right. Right tribe.
Well.
Right tribe.
Right.
Yeah. So another part of this research, it said human experiences can influence genetic phenotyping, the soft genetics, like stress reactivity, which determine the individual differences in vulnerabilities for affective affective disorders. So that's amazing, because what that says is literally what you do at any point as far as how you create resiliency literally changes those genetics. Does that make sense?
Yeah.
All right.
Yeah, it powerfully makes sense.
And you have the THP2 gene. So like when we do our epigenetic protocol, we'll do that 23andMe test, which you can just get, right? I mean, anybody can get that test. It's like $185 or something. And you spit in a tube, and so it's very glamorous. And then you send it in, and then 4 to 6 weeks, you get your DNA report back. But the DNA report that they give you is very, very limited. The DNA report that that's also included that they don't interpret for you, which is like a 65 meg text file, then that goes to people like me, and I can put it in software, and I can see every possible gene in your body, like 650,000 genes, and I can look at the genes that regulate, the 12 that regulate this condition, the 14 that regulate this condition, and actually look at your genetic predisposition for pretty much any disease, but really also look at those very specific psych ones that we want to say, are those genes that we need to actually modify specifically for you, that's unique to you, right? So regardless of what's all happening in your life, can we change that? And then with depression, the main gene that people talk about with depression is that methyl tetrahydrofolate reductase gene, right? So that gene looks wildly inappropriate. Yeah?
MTHFR. R.
Yeah.
Spell that out in your mind, and that's why we call it wildly inappropriate.
It should be the Samuel L. Jackson gene from Pulp Fiction. He say what again? Methyl tetrahydrofolate reductase? Right. All right. So those of you seen that, you might get it. I don't know. And then you have several other ones. Now, there's more genes for depression than there is anxiety. One of the main ones, which is really interesting, is that BDNF, right? And it's brain-derived neurotrophic factor. And that's one of the coolest things that we're doing with neuroplasticity these days, where we want to actually improve brain function. So when they say you can't teach a new dog old tricks, no, can't teach an old dog new tricks.
Right.
You can't trick a dog into tricking another dog into new tricks. No. All right. So you can't you can't teach an old dog new tricks. That's what we say, right? Once you're set in your ways, you're that's how you are. But we know neuroplasticity-wise that at any point, so the studies that came out in the 90s were the first studies that actually showed that we can teach an old dog new tricks. That we literally have the ability to dramatically modify our brain and nervous system, okay? So that's neuroplasticity, the ability to change and modify and overcome. But that is based off a hormone called BDF, right? Or brain-derived neurotrophic factor.
BDNF.
BDNF, yeah. So, interestingly enough, I was looking at some research about that too. So that's another epigenetic modifier, or epigenetic gene that's important for things like depression. And it says epigenetic structural adaptation represents changes in chromosome genes, for registering, signaling, and perpetuating altered activity states. So what the heck does that mean? That sounds crazy.
I was posting about genes.
So it means we basically can control our output. So the way that our brain functions, all those kind of things. Okay. So people that are set in their ways, they literally can change this gene and then have the ability to modify that. And like if we go back to that mindfulness idea, studies show that you can change and modify your brain by 30,000 neurons, rearranging 30,000 neurons based on altruism and mindfulness within just 2 weeks.
That's amazing.
Yeah. And so when people say, well, that's just the way I am, well, great, don't be that person, right? But the how-to, that's the hard part. And if mindfulness is hard, well, then you really need it, right? If yoga is hard, you really, really need it. Just like, I can barely walk down the stairs. Well, great, you really need to start walking down the stairs.
Yeah.
So you become stronger. And so we want our brain to become stronger, and these genes actually modify and regulate that through that epigenetic pathway.
Yeah. That's a powerful point, just going against the grain, going against what's easy, choosing to do something different than just follow the path of least resistance where this is concerned.
Right. And as Americans, we kind of get shortchanged because we have this defeatist kind of mentality even within medicine of just, you're broken. We'll take a drug to modify the symptoms.
It's because we're overworked and tired. We're overworked and tired.
I got 4 kids. So
he's like, I don't want to hear it.
Anything less than 4 kids, it's like a vacation. So the other thing that they said, this was really cool, is in that research they said the non-genetic factors, so that would be lifestyle, environmental toxins, chemicals, all those things. Non-genetic factors induce these genes to express themselves differently. So again, everybody has the same gene, but they express it differently. They have different outcomes for anxiety and depression. Thus, epigenetics provides a possible interface between the genetic and environmental factors that in combination produce that phenotype or your gene expression. And what that says is the most powerful thing you could ever hear when you are chronically sick, which is you have the ability to overcome those genetic predispositions.
It's the bridge.
It is the bridge.
Yeah.
And like even 23andMe, people get those genes tested, and the FDA didn't let them do the reports because they said it freaked people out. Because they thought, well, if I'm predisposed to diabetes and I'm getting diabetes, I might as well just eat whatever I want. It's genetic.
Right.
And what this research is saying is the same thing, which is no, don't be that person.
You don't have to be that person.
Yeah.
Right? Yeah.
And so, although with depression there's lots of different genes, there's actually they're literally doing a little bit of proteogenomics with drugs, where they're actually taking your genotype and then prescribing your pharmaceuticals based on that. But we do the same thing, but we do it with supplements. So there's reasons why some people, like 5-HTP will work on some for depression, but it won't work on others. There's reasons why St. John's wort might work on one person, but not on someone else.
Yeah, that's
those epigenetic mutations.
That was something I was wondering about. Like, where are we going with this testing? What are we finding out? We're finding out what kind of, on one hand, what kind of pharmaceuticals we might want to prescribe, but on this hand, it's what kind of supplements. So
right.
I'm just sort of reiterating to.
And you kind of assume, like, if you're one of those people that medication never works on, then it's probably there's a mutation in that pathway, and it's not going to work. So, now with gene expression, there's a couple ways that we do it, but one is histone modification. So if we talk about histones, that's like the recipe for your making a bundt cake, right? And so basically, if you messed up your bundt cake, someone would go back and look at the recipe and like, oh, here's where you messed up. Let's redo it and fix it. So that's how your DNA polymerase knows how to code or check the code for that gene, is through histones. So we'll talk about histone modifications and even things that we can do to regulate that. And then the most important thing is inflammatory regulators. So there's lots of like biomarkers of inflammation that are linked to genetic predispositions for anxiety, depression, personality disorders. Even one of the guys that we're trying to set up the top trials with, clinical trials, he did research on that back in the day too, which was really, really impressive. I think they were looking, I think it was on too much time, but it might have been cyclooxygenase pathway or lipoxygenase pathway. So, but basically, let's say in that there are inflammatory chemicals or inflammatory pathways that are built in that, when upregulated, actually cause anxiety and depression, and we can actually then regulate those pathways.
Yeah.
So.
Yeah.
So if we look at this in the clinical perspective, so this is one of those things of like, okay, well, here's all this research, and if you go on PubMed.org, you can look up as much of this research as you ever want on genetics, epigenetics, anxiety, depression, any of that stuff. And it's pretty in-depth, complicated stuff for the most part, but it's all published. That's what's amazing to me is when I look into this stuff, it's not magic. It is like well documented, well published, well researched, and even the research publishes like 300 references, and it's just like, holy crap! Why are we not doing these things? Mm-hmm. And so one of the things I had to do for that first patient was I had to come up with a treatment protocol, and I had to do it based on evidence-based research. So here's a few things that we want to talk about. So these are all things that you can eat, and think about, do I eat these things? And should I eat these things then?
So we talked about this last week. Like, this was what we were starting to get to, and I asked this question last week. Well, what do we do? What's on average, what is it that you do? And so this is what we're getting to right now. So
right,
listen up.
All right, time to take notes.
Okay.
So one of the things that you want is methionine. Methionine helps create what's called S-acetylmethionine synthesis, and that pathway is through methyl B12. Now the nice thing about methyl B12, so anytime I prescribe supplements to patients, always do methyl B12. And that methyl then goes and methylates or turns on genes, which is awesome. So then you can upregulate the genes that you want, silence the genes that you don't want. But that B12 converts homocysteine into methionine. And when it does that, it then helps regulate a pathway for mood and sleep. So some people have mood and sleep problems, because they don't get enough B12 because B12 is made from gut bacteria. They took antibiotics to kill off the gut bacteria. So then they should be anxious and depressed. And you'll even have patients sometimes that are like, man, I felt great, and then I had to take this antibiotic for this pneumonia, and then I've never been right since. I've just been anxious. I've been overexhausted. I felt depressed. And it's like, yeah, and they can't explain why, but this is why. You have to have those pathways. And we don't really get a lot of B12 from food. We don't even make B12 in our body, but our 750 different species and 3 pounds of gut bacteria, these hundreds of trillions of bacteria that live in us, they make the B12 so we can be healthy and happy. So that's why it's so important. So when patients are in crisis for anxiety and depression, always methyl B12. Always, 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 because of that pathway. And you can also get methionine by itself through B12 pathways of other species. So like sesame seeds or tahini. Brazil nuts, which again, 2 Brazil nuts is 200% of your selenium needs for your thyroid, so that's even better. Wild-caught fatty fish, which is the staple of every healthy, longest-living population on Earth. Wild-caught fatty fish. Salmon, halibut, mackerel, cod, sardines, anchovies, right? Good little anchovy peanut butter sandwich. Bam! No, okay. Peppers and spinach. And again, it's in tons of stuff. So if you eat real food, it's not really a big deal, really, to get that. But if you take antibiotics, you kind of screw that process up.
And those are all foods for methionine?
Right, just for methionine. Let alone you make the methionine through B12.
Okay.
And then folic acid, which is wildly profound for epigenetics. So that's that pathway where you see a lot of research where they're like, you can't just take folate, and folic acid is synthetic folate, and you got to take methyl tetrahydrofolate, or, you know, all that kind of stuff. And for some of the people, it's true. But I think it's only like 10% people have, 10% of the population will have that issue. But without testing, just take the reduced B12 or folate and just be fine with that. So you want to take like that methyl tetrahydrofolate or methylene. It's folinic acid. So you want to reduce one that's past that methyl tetrahydrofolate reductase. It always sounds crazy, like I'm just talking nonsense with that.
By the way, we've had a couple of questions on like what kind of dosage and things like that, and Dr. G will go back through and follow up on a lot of these questions. So if you've got them, go ahead and ask.
Right.
We may not be able to get everything on there right now, but we'll get to it.
And, you know, endogenously, you just want lots of good bacteria. So your probiotics are actually going to be your preliminary dose for B12 and folate and B6 and all your B vitamins. But if you want to take it like a therapeutic dose, I mean, typically with, you know, B6, you want that methyl B12. I usually start with like 5,000 micrograms. And it seems like a lot, but it's actually not. It's a very tiny amount. It goes under your tongue. What's really messed up is people that take opramazole or proton pump inhibitor, literally cannot absorb B12 through the gut then. Because the same pump that pumps out acid for your stomach, so it can break down food and you absorb the nutrients, it actually produces intrinsic factor, which binds to B12, which is how you absorb it. So if you take acid blockers, you need to just not have reflux, and that's a whole other discussion. But it's very easy to get rid of. If you have it, though, you have to only do sublingual. So usually if we expect any kind of gut problems, just take it sublingually, and you use a little tiny thing, stick it on your tongue, you're fine, okay? So that's empirical dosing. That's just like, you know, if I have no idea what's going on with you, that's what you'd probably take. With the methylfolate or those kind of things, I'm typically not really brand specific, but there's other brands you can take. But coenzyme B complex, it has all the B's in there, the reduced form for most of them, so like P5P instead of B6, methyl tetrahydrofolate instead of folate. Those are highly, highly absorbable because they've already passed that enzymatic pathway, and so that's a really good standard dose, just like 50 milligrams to 100 milligrams. The only caveat is you probably don't want to take it after dinner because that B6 might make you feel like really awake, not amped up like caffeine, but just, I'm awake.
Alert.
Alert, yeah.
Yeah.
which may be good, but if I'm doing paperwork till 2 in the morning or doing research, man, I will amp up on those B6s, but I pay the price. I mean, at 4 in the morning, I'll still be like, guess I'm watching TV. So folic acid. Now, folic acid is really easy to get. With folic acid and your B's, typically, you think beans, greens, and fermented foods.
Beans, greens, and fermented foods for folic acid.
Yeah. And lentils is like 90% of your folate. 90% with one serving of lentils. Do you eat lentils? That Amy's has lentils, don't you?
I like lentils, but I haven't. It's not my go-to. Hasn't been my go-to, but it should become my go-to.
It really should. And what happens is folate, methylfolate, actually then methyl goes and helps methylate DNA, turns genes on and off. But the folate helps convert with choline into phosphate titylcholine and phosphate titylserine. And those two things are what makes your brain work. So those are some very expensive supplements, but if the supplements work, then the question is, why the hell am I not making this stuff? I'm supposed to be making this. So instead of using folate and these other pathways to make stress, we saturate them so you can make happiness and think clearly too.
Yeah. Can we talk about beans just for a second?
Yeah. Uh-oh, I know where this is going. All right.
I think we've had this conversation before, but I've forgotten it. So what if you just react to beans and that is uncomfortable?
Like gas.
And you don't eat them as a result of reacting to them, what should you do?
Are we talking gas or sharding?
All of the above. Bloating. Bloating especially.
Yeah,
gas. So the gas.
Yeah. So it's, beans have sugar and fiber in them, right? Which is good. So the carbs then bind to the undigestible fiber. You don't digest that. And then you rely on your gut bacteria to digest that. And if there's an imbalance in that gut bacteria, sometimes it'll digest that and make way too much things like methane, which then becomes gas and bloating. Typically, that can be restored by a good multi-probiotic, like Ultraflora or Raw 50, Women 50 and Wiser. Some wide spectrum, 18 strains to 33 strains to 30 billion to 90 billion probiotics. Typically, that's it. But, you could react to the saponins or the phytic acids. And if that's an issue, so typically if you have good bacteria, you drink kombucha and stuff.
All the time. Yeah.
Do you take a probiotic?
I do take a probiotic.
Okay. So it may not be that for you. It may be more of irritants, which are just environmental irritants that are in the food. So if you have problems with phytic acid or saponins, basically you just want to make sure you wash the beans and soak the beans before you eat the beans. So then if you do canned beans, you'll notice when you open them up there's suds in it. And that's saponins. And you can pour that around plants, and those saponins actually protect the plants. So the beans actually have saponins on there to protect them against bugs.
Are canned beans better because they're in water and therefore soaked?
No, so those are the worst because they're also lined with a little estrogen. They usually have flavor enhancers and stuff and preservatives.
Okay.
So, simply organic, it's just, I think, beans and salt and water. Wild oats, brand, beans, salt, and water. But the other ones have crap in there. I spend half an hour at the grocery store trying to find beans.
So it's better just to do it yourself, maybe.
Right. So if you buy dried beans, that's the best. Now that's where lentils come in handy because lentils you can put in your chili or you can put in your soup, and by the time the soup's done, they should be soft already. You don't have to pre-soak them.
Okay.
But if you have phytic acid or saponin issues, then you want to pre-soak those beans, rinse that off. Pour out that water. You can pour it on plants. It's super healthy for plants. But pour it out, soak it a little more, and then use them.
Okay.
And so that will usually, if that's the issue, that'll get rid of it.
What about enzymes? Won't those help too?
So yes and no. It depends on what the actual cause is. So some people maybe don't break down the food, so then they have these irritations and then maybe they get gas or cramping from that. So those patients, enzymes work beautifully with.
Okay.
Right? And that's okay. There's no problem taking enzymes. In fact, a lot of antibiotics that people take mess up the enzyme production of your organs. And so you want to do some enzymes, cook your food really, like just soft, so like lightly steamed, not grilled and stuff. But then it's easier digestible. And then usually within a few, maybe 6 weeks to 8 months, 6 weeks to 8 weeks, you should be able to go off the enzymes and digest your food perfectly.
And be fart free.
And be fart free, yeah. Yeah, because there's times, I mean, again, most people have noticed that at some point, if I eat Pintos, I get all this gas, but then sometimes when I eat Pintos, I get no gas.
Okay.
Right?
Okay.
I ate we had a drug rep. I shouldn't tell people about this. But we had a drug rep, and they brought some refried beans. And so I was just like, I'll take refried beans home, and because we have some organic corn chips, and so it'd be fine. And so I was eating it, and I ate probably like half the container. And then I thought, oh my God, everybody's going to hate me for this. I'm going to have so much gas. But I didn't have any gas.
Okay.
So again, it was just what's going on with my gut.
Okay.
At that point.
Okay.
So now, B12 we talked about. Or so the other thing with folic acid, beans, greens, gut bacteria. Also, nutritional yeast is an insanely therapeutic dose of B vitamins. Now, that's not the same as baker's yeast and brewer's yeast, but nutritional yeast is typically what vegans use as cheese. And so it's good on popcorn, pasta, kind of what you'd use for Parmesan. And I never had it because I'm not very brave with this kind of stuff. But I actually had a patient that brought in supplements and some foods for me to read the labels. And she had nutritional yeast, and I asked her if I could taste it. And holy crap, it tasted fantastic.
It's good. I like it.
Yeah. It reminded me of when I was a child eating at Kentucky Fried Chicken, original recipe chicken. That's what the memory that was tied to that in my head. So I was like, holy crap, I'm going to coat everything with this stuff. This is great. You like it?
Yeah, it has a nice. They've got some popcorn that's seasoned with nutritional yeast that you can buy.
Yeah,
and it's great.
Now remember, there's bad yeast and there's good yeast, and really, there's not even bad yeast. There is overgrowth, and that's really where good yeast turns bad yeast.
Overpopulation.
Right.
Yeah.
So it's cool when your sister has 3 kids. It's not cool when she has 12 kids. Okay, so that's the difference. Right. So. Beneficial yeast is nutritional yeast, and sometimes people will be like, oh, I can't have that because my doctor told me to stay away from the yeast. Actually, that yeast is going to protect you against candida. So,
which is a different type of yeast.
That's right.
Right, okay.
Yeah. So, B12, which is, there was a thing from Berlin. There's a bunch of vegans there now, like 80,000 vegans. And so then they were asking the German government, this on NPR the other day, to come out with a statement whether being a vegan was healthy or not. And they said, being a vegan can be dangerous because you don't get enough B12, and that can cause a lot of problems. But what's just idiotic about that statement is the animals that we eat to get the meat do not make B12. Did you know that?
I did.
Yeah.
Only because I know you.
Oh. Okay. So, the way the animal gets B12 is it has gut bacteria that makes B12. The reason you could be a cannibal and be super healthy is because you'll eat people with gut bacteria that makes B12. So whether you're a cannibal...
Right, or a vegan.
Or a vegan, which are probably the... You can't get more opposite than
sides
that.
Of the coin.
You still get your B12 from the same place. So...
It's not that you have to become a vegan or cannibal.
Or cannibal.
It's just know that. That's where B12 comes from, is your bacteria.
That's right.
Okay.
I always had a plan. If I was a bum, like if everything all failed, I'd be a bum. I'd live in a box, and I would eat cats. And then I'd get all my B12 and all my nutrients from the cats. Plus, so they're warm in the winter, or they're warm during they're fun, but then if times get tough, you can always eat them.
You know what's crazy? First, I thought that was horrifying to hear that, but then I remember hearing about someone who said if the world ended, cats and like what is it, cockroaches or something,
Right.
would survive.
Right.
So there probably would be plenty of them.
Yes. Yes. So
We're
that's
we're
my
not
plan.
condoning cat killing.
No.
No.
It'd be humane. But that's my backup plan. Because cats breed like crazy. And they can eat stuff you can't eat. It makes a lot of sense.
Vegans, close your ears.
Makes a lot of sense, right? All right, so then there's SAMe, and SAMe is not only a very wonderful thing for mood and sleep, but SAMe is what takes tryptophan and makes melatonin out of serotonin. So a lot of times people take melatonin, but you don't want to do that. You want to take SAMe to make melatonin, but you get SAMe from converting methionine from B12. And so it goes back to B12. That's why B12 helps with mood and sleep. Let's see. And again, the way you get SAMe is probiotics. It's good bacteria. Because good bacteria makes B12. And we actually, for people that have really bad histamine issues, the first goal is to identify, get rid of those things. But you can also take SAMe to make methyltransferase, which is the fastest way we actually break down and excrete histamine overproduction. So, just side note. Which, again, can cause anxiety and depression. So, you get like multiple benefits from SAMe through B12. But you can buy SAMe, actually. They just make bacteria make SAMe and then package it and sell it to you. They sell you back. They sell you what you should be making, but you took antibiotics, and so now you just buy it instead of making it.
Right. And so this, on that note, this is not the end result, is to just be on a supplement either.
Right.
This is just a step.
Yeah, so we're talking about anxiety and depression, and with epigenetics, we talked about, America's the #1 anxiety and depression. In the entire world, we're #1 for feeling horrible. But if you look at these foods, that's just what the rest of the world eats. That's what we all ate when we were immigrants coming over here, and we changed over to creating an American homogenized, processed, crappy diet, and then did lots of drugs, and basically screwed it all up. So when you look at all these foods, it's just real food. This is why you don't have gorillas trying to figure out which psychologist to go to out in the wild, That's why zebras don't take antidepressants.
You heard it here.
But pets are a different story. So one of my patients, hopefully they're not listening, was talking about atrial flutter, right? So that atrial flutter. And so then I said, well, you don't have to have it. It's messed up. Here's how your nervous system works to your heart. Here's the biochemical process. Here's how we mess it up. And that's when you get it. And when you stop doing that and you put the nutrients back in there, the heart just works. And he said, well, how many patients do you have that haven't been able to get rid of it? And I said, 0. There's been 0 patients that I've had to send for surgery.
Wow.
0. And so then I made that example of well, that's why animals don't have arrhythmia. And so then he went to the electrophysiologist for his appointment and kind of asked him a bunch of questions. And he said, surprisingly, he was very detailed, just like me, gave lots of really good explanation. And then he said, well, do animals get this? And the guy said, yeah, animals do. And so then when he talked to me about that, I said, well, let me look this up. And then sure enough, and of course it has to be, but it was animals in captivity. So like at SeaWorld, dolphins will get heart flutters, but that's because we don't necessarily feed them what they would get out in the wild.
Has there been testing on wild animals?
I don't know. So it's kind of a fail-safe for me to say it because there's not Holter monitors on gorillas out in the wild. So.
Right. But we do know.
But I know
that
with humans we can reverse it.
Right, and we do know that animals contract the same disabilities and diseases that
when
Western medical
when they become pets.
When they become pets, right, because they're exposed.
So I think the #1 drug for pets now is diabetes medication.
Yeah.
And I'm thinking I heard this the other day, but the #2 is anxiety medicine.
Yeah, I believe that.
So you take animals that are healthy and happy, feed them like Americans, except for animals, and then keep them in captivity, and then they get the same diseases that their owners get.
It's not to say that we don't understand like the struggles of, people who have pets and they're struggling with that. It's not to say you're bad or wrong because you've medicated your pet. You're just trying to help them. Right. But it's just interesting that they suffer the same, they're suffering in the same ways that we are as humans, and most of that is because of lifestyle and environment and, attention.
And then choline, which is a very, very potent source of choline for phosphatidylcholine, from brain function, and same with the betaine. But those actually help convert and donate methyl groups to DNA. But they come from things like egg yolks, which is one of the things that they tell people to stay away from because of cholesterol, which is absolutely ridiculous. And if you have anxiety and depression, do not mess with cholesterol. You want cholesterol because cholesterol is progesterone and testosterone, and it's an aging hormone. It's vitamin D. It's everything to make you healthy and happy.
It makes all those things.
Right. Yeah. And so if you're like, well, your doctor says, well, the reason you're depressed is because you're low on vitamin D. Why am I low on vitamin D? Well, you're taking a drug to lower vitamin D because it's cholesterol. So we end up exacerbating it.
Yeah.
And then, meat, but with choline, it comes from meat, but also we get that basically from what that meat eats too. And then resveratrol is an epigenetic modifier too. And that is typically through red wine or dark grapes. So not green grapes really, but dark red grapes. So typically most Americans eat green, but we want to reverse our mutations in our DNA and regulate anxiety and depression through the genes. We need to be eating Concord or purple or black grapes. Always the darkest fruits and vegetables, or the richest colors with that, are the things that are going to reverse our DNA mutation. But then red wine. And, if you look at the countries that live the longest, healthiest lifespans, they all consistently drink red wine. And whereas America, we drink beer, which is a lot of drinks from alcohol, but it's usually like a beer is just a soda with alcohol. Mixed drinks are just alcohol with a bunch of petroleum chemicals and flavors in them. And then white wine is just, again, candy with alcohol. So, but when you get to red wine is truly medicine. It's truly therapeutic. And so if you say, well, do Americans eat or drink a lot of red wine? No, they don't. But the rest of the healthiest countries in the world do. The people that aren't anxious and depressed. The other thing is that same kind of notion we talked about before, where something like 80% of Americans eat alone, and 80% of everybody else in the world eats in groups or right tribe. That's that same kind of mentality of it's not just the red wine always; it's the red wine with company. Mm-hmm. So you tend to sip red wine, not gulp red wine.
Right.
And so then you actually are able to socialize in right tribe a lot better.
Yeah, red wine with company, with the right pacing, with the time created to slow down.
Yeah.
Yeah.
And then the next major nutrient that regulates is probably the most controversial, and that's genistein. And it's the same as diazepam, but genistein is from edamame or soya. And so as long as it's organic soy, it's fine. If it's fermented tofu that's organic, that's even better. If it's natto, it's even better. That'll break down scar tissue, break up clots, awesome stuff. It's just super disgusting, right? At least it looks disgusting.
Is tofu always fermented? Is that part of the process of making tofu?
Well, that's a good question. Don't ask me questions I don't know. So I think it's fermented a little bit to make the original tofu. And then they ferment it even more to make what's called fermented tofu.
Okay.
Like maybe sprouting it. Or sprouted tofu, yeah. So, tofu is fermented, and then there's sprouted tofu. And that's even healthier.
Okay.
As long as it's organic. Now, the reason that they demonize it is because it has phytoestrogens. And phyto just means plant, so the plant-based estrogens. And so then they think, oh my God, I'm going to get estrogenic diseases. But in the countries that eat tofu, they do not have estrogenic diseases. They're actually protected from those. Even with synthetic estrogens, it actually protects against that. So again, we're that country that we eat 150 pounds of sugar, and we tell people not to eat potatoes because they're too high in carbs, right? We're the country that then says, will take birth control, take hormone replacement. We know it'll absolutely guarantee your risk of cancer by 30%, risk of heart disease up to 87%, but don't eat soy because it has a naturally occurring estrogen in there. We're crazy when it comes to that. Crazy.
Yeah.
So don't buy into that. I mean, again, the truth is always this simple. If what I say is true for you, then it's true for all of us. If it's true for all of us, it's true for the healthiest and happiest countries in the world. If it's true for them, then it's typically true in mammals around the world, right? So it's not that complicated. Long before we knew any of this stuff, we still live long, healthy, quality lifespans. And so the populations that live the healthiest and longest and happiest in the world, they're not like doing weird, gimmicky diet crap like we do in America.
Right, right.
And demonizing food while we consume chemicals that cause the disease.
Yeah.
Yes.
Do we want to leave something left over for next time, or do you want to go ahead and get through all the rest of it?
Well, so how much time do we have?
We're right at an hour.
Okay. Yeah. Well, let's finish up here real quick.
Okay.
So one of the last couple things is you have sulfur groups, and that's from things like brassicas and onions and garlic. So again, onions and garlic should be the staple of our diet, and in America, no, that's not what we do. So we want lots of garlic, lots of onions in our food, and even in French cooking, there's what's called mirepoix, and mirepoix is carrots, onions, and celery diced up in a little bit of olive oil. Heat that up, and then you add your garlic and the rest of your food. And that is the staple of every food. No matter what you're making, usually you have to start with mirepoix. So that's getting you all those nutrients. But you want those. And then the other thing is the DADs. And they're sulfides that are typically specifically to garlic and onions. So lots of garlic and onions. So basically what we said so far here, to regulate our DNA, to affect gene outcome, we talked about nuts, seeds, greens, brewer's yeast, omega-3 rich food, which is wild-caught fatty fish, egg yolks, spinach, which is greens, red wine, tofu, cruciferous vegetables like broccoli, cauliflower, celery, crunchy kind of stuff, kale, bok choy, onions, and garlic. So if you had to take all those foods and create a diet, what would that diet look like? And we could name it by a name for the most part, which is the Mediterranean diet. That's literally the Mediterranean diet, not the Americanized Mediterranean diet that you'll see in cookbooks in the U.S.
What's the difference? I mean, can someone go and reference this Mediterranean diet that is not in the books in America?
It's typically going to be like where you see like oil. So if it says olive oil, it's probably Mediterranean. If it says butter for everything, it's not. And it was very hard. Like when I first started trying to find Mediterranean books for patients, it was actually hard because they Americanized them and they messed them up. So they basically took something great and made it worse.
It'd be great if we could maybe post a reference, find a good reference and post that for someone to go to.
Yeah. So someone should ask a question, so I remember to look for it. But, what's a good Mediterranean resource? The other thing is, that's what I love about the simplicity of this, is, I mean, when we have patients that have real conditions like that, we can look at the genetics, we can look at the soft genetics, the hard genetics, but basically that outcome, and then say, how do we fix this? And a lot of time, it's very simple. It's simple to cure, but complexity makes more money. Complexity sells, simplicity cures, right? And if you look at those dietary changes, it's not all that complicated.
Yeah.
I mean, people will end up coming in with like 20 supplements for their anxiety, depression, and it's just like, this is food, this is food, this is food, this is food. Just eat some food. And if that doesn't work out, then we can kind of like add in supplements to kind of magnify or restore things faster.
Yeah.
Yeah.
Now, on this list here, I posted all of these as we went through. I posted those words. Yeah. As we went through.
Very nice. Yeah.
And so, but I want your guidance. What would be, I mean, someone could theoretically say, okay, I'm going to go supplement with all of those. Do you know what I mean? So,
yeah.
is that a good thing or a bad thing? Should we start with food first?
You should. But if you started with a good overall probiotic, which we talked about, if you then use coenzyme B complex, which is a good reduced multivitamin, and if you did methyl B12, you would cover the bulk of all these. And that should be that underlying, like that's that kind of like, and don't do wheat and dairy and don't do chemical. There's all these things we can add on, but those are those underlying basic things that run. That's the oil, the gas, the antifreeze that runs epigenetics.
The probiotics, the coenzyme B,
and the methyl B12.
and the methyl B12. But can you find the methyl? You could probably find the methyl in a
super easy to find.
In a B complex.
No.
Right?
So you want because they'll have like 500 milligrams, and you want like or 500 micrograms, but you want 5,000 micrograms
Of the methyl B12.
Of the methyl B12.
Okay.
Or they'll have cyanocobalamin or something else that's not as effective.
So those are a good 3 to start with, and then food.
Right, and then just trying to eat real, actual food.
Whole food.
And luckily, that again, don't buy into the propaganda of wheat and dairy as a part of a wholesome diet, because that's not what a gorilla eats, right? A gorilla's healthier and happier. What does it eat?
Cheesecake. Gorillas eat cheesecake, people.
Cheesecake from nut butters. Like a pistachio, like lotus leaf in Wichita.
Yeah.
They have a cheesecake made from pistachios.
We're going to Lotus Leaf.
It is freaking awesome, right?
After this.
Yeah.
I just didn't even know there was an alternative.
Oh, it's good. And I think their crust is gluten-free. I think it's like some kind of nuts or seeds. I think it's nuts that make up the crust, and then they have the pistachio. It was great.
It is a really good place to eat. Lotus Leaf, you're getting free marketing here.
That's right.
We
Send me my
like you.
check. Where's my check? Where's my free meal? Yeah, so Lotus Leaf is awesome. That's a good place to... it's kind of a hippie place for that kind of stuff. So, like, I ate a bean burger there, some sweet potato chips.
You can't. They require you to have a man bun.
Cheesecake. You gotta have a man bun.
You have to have a man bun for entrance.
That's right.
No, you don't.
No.
Okay.
So we talked about genetics. We talked about epigenetics. We talked about some very specific genes. We talked about how those genes can affect your outcome or your behavior. And then we talked about very simplistic epigenetic approaches to dietary things that you can simply do to help reverse that outcome.
Yes.
And modify those genes. Literally change those genes. And then we talked about some supplementation that you might try as preventive. And then again, if all else fails, just come make an appointment and figure out what we're missing or something like that, because usually it's just not that complicated. So, and there's only a few patients that I worry about once in a while that are like, oh, I hope this works, because they're a really tough case. And then after a couple weeks, it's just like, okay, I'm starting to feel better. So it's like, okay, all right. We had a lot more work to do than I thought with that patient. So feel free, continue to post your questions. I'll try to answer those over the next day, and then try to follow up. If you ask multiple questions, or if you have very specific stuff, maybe message me on Facebook, because it does this weird thing where if I answer a question and someone posts, like if there's like 85 comments, it doesn't tell me where in that comment when I go to answer it. So I have to literally look at every single one. And it's like, holy crap, they need to fix that. So if it's multiple conversations, maybe just message me. And that way it's super fast and easy for you. The only unfortunate part is maybe people don't see it, I guess. So I don't know.
Right.
I don't know. Decide what you want to do. I'll try to be vigilant about that.
At least tonight, it's nice to have them on the feed,
right.
But later, yeah, that makes sense.
And then if you try these things and it don't work, then just feel free to make an appointment or something, and we can figure out what you're missing. My office number is 316-636-2888. And if you want to sign up for like yoga or something like that, and kind of mindfulness, you can call that same number and start that, because that's very important when it comes to all this. You can supplement the hell out of your genes, but you can't supplement your way out of bad thinking and a crappy lifestyle.
Yep.
Right.
And free yoga this Saturday. This Saturday, free yoga at 3:30 at 1855 North Webb Road.
Behind Barnes & Noble at the dumpster.
That's exactly where we do it.
No, that's not.
We want to be real.
No, the downstairs, you're doing it here?
Yeah.
Yeah, so we have a great yoga and Pilates studio downstairs.
Yeah.
And so free, you can't beat that.
Nope.
Yeah.
Nope.
Except you could pay them to come. That would be better.
I could pay them to come.
Pay them.
Right,
That
would be better.
So thank you guys. Take home messages. What do you think?
Just that your DNA is not your destiny. That would be my biggest take-home message, which is just a really hopeful message that you can make change. We say this every time, but
It's hope.
it is hope, especially for those who are just joining us for the first time tonight. It's hopeful. There is something you can do to help your body, to feel better, to change your life. And we know that these things are legitimate, tried and true and tested things that you can do.
Yeah.
So.
Yeah, my take home is just your genes are not your destiny. I told her he said that's what I was going to say. But that's what I'm going to say. It's great. Because, it's so hard. It's just like, this is how I am. Well, that's not how you have to be.
Yeah.
And I love that. You have the greatest control over how you think and how you feel. And it's not about, medicating the symptoms of a bad lifestyle. It's not medicating bad genetics or bad, expression of those genes. It's what can I do to see if I can not need medication? Or what can I do to see if I need less therapy or get better therapy or more effective treatments? Or even if I'm taking the right, supplements to even help, or are they effective for me? It's one of those things of like really clarifying that complexity. I have tons of books that make it way more complicated than it really should be, but in clinical practice, the goal should be how can we be the most effective with the shortest amount of time, being most respectful of resources of the patient. And, trying to reverse it's probably and stop causing is the easiest, cheapest way you can ever do anything. Mm-hmm. So.
And long lasting.
That's right. That's right. You're not dependent on me. Here's the path, and you know the path.
Yeah.
So, well, I'm glad you guys were here. Please feel free to still share and like. And I think I said this last time, but someone at the state fair actually ran across the Broadway and was like, I watch all your stuff. So it was kind of cool. So, and then people at the front are actually recognizing and saying that Holly's famous now. But, this is really good information, I hope, and please share it with people that are suffering. At least the bare minimum that we hope to do is to plant seeds that people know that they can get better.
And to become famous.
That's why I make all these great jokes.
That's the most important part.
Right.
Yeah, I'd like to just say that too real quick. Thank you for your comments. Keep making jokes, because those are great. And
Tiffany.
Tiffany and Kim, the troublemakers of the group. And really glad to have you come back next week for case studies.
Oh yeah, next week's case studies. And then next month we'll start a new theme, and we'll talk about what that theme is then. So a little cliffhanger for you guys.
Yeah, if you've got requests for the theme, throw those out.
She wants rebuilding hormones naturally.
Hormones.
I'm thinking how to have a drug-free pregnancy. So you gotta have to help us. You guys tell us what you think.
Maybe we could do both.
Yeah.
Those are both women's issues. Well,
right.
No, they're not both women's issues. So, okay.
I have hormones.
You do have some hormones.
All right. Bye, you guys. Thanks for attending. You gotta pretend like you're fake talking like they do on the news.
Did I end it?
No. You don't know what you're doing.
Bananas.